Alright, so let's go ahead, you guys, and do some area of triangles. Mr. Smith and I were actually talking about this morning, you guys. This chapter is probably, or unit, is probably the most important one you're going to learn in trig. We learn law of sines, law of cosines, and now we're doing area of triangles. And you guys, out of everything you're learning in trig, this is the one you're going to use the most often. It is actually super useful. So hopefully you're doing okay on this. It's looking like people are doing pretty good. So we're going to do area of triangles now. So I'm not going to go through how to derive all of these formulas, but they all come from the area of a triangle formula that we know, which is area equals 1/2 times the base times the height, or base times height divided by 2. So these all come from here. There are a couple really important things that you need to know, though. This formula is the formula you're going to use for side angle side. This formula is for side, side, side. So you definitely have to know those. S in this other one stands for the semi-perimeter. Semi-perimeter is all the sides added together, so all the sides added and divided by 2. It's called a semicircle, you guys, because you're adding the whole outside. You divide it by 2, so that would be half of the circle. So you're adding all of the outside, divided by 2 would be half of the circle. Yes, we're talking about triangles, but that's where the term semicircle comes from. Makes sense, actually. So let's go ahead and just go through one of these problems real quick. It says the side lengths of a triangular traffic sign are approximately 27 centimeters, and we don't know the other one. The angle between the given legs is 40 degrees. Approximate the area of the sign. Round your answer to the nearest whole centimeter squared. So I'm just going to draw a triangle A, B, C, and then we know we've got 27, and the angle between them is 40 degrees. So we've got side, angle, side. That means we're going to use this formula. So area is 1/2. You know what? Just to correspond with these, I'm going to go ahead and erase these, you guys, and label them on the sides that are in this formula, just for you to get some help on this first one. So I'm going to label this one 40 degrees. Sorry if you already labeled it, because this would now be side A, side B, side C. So we've got AB is 27 times 27 times the sine of C, which is 40. And this is just a calculator problem now. This is degrees, so make sure your mode is in degree mode. And go ahead and type that in your calculator. Alright, when you type that in, you should get your area is approximately 234 it's 296, so I'm just going to say 0.3. And then we're talking in centimeters, so we're going to say centimeters, and its area, so it's squared. This would be our answer. Let's go ahead and do the next one. Alright, I always start out, you guys, I draw the triangle every single time. So I'm just going to draw, and you guys know this, I've drawn the same triangle since I was in high school doing these. So ABC, BAC, the side across from the angle corresponds with it. If A is 15 feet, and B is 18 feet, and the measure of angle C is 100 degrees. That's perfect, because now we've got side, angle, side. That's what we want. This is honestly, you guys, out of the two of them, I love it when I get side, angle, side versus side, 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 because I just think it's so much faster. So here's our equation again. This is probably something that you want to know off the top of your head, but obviously you're just learning it right now. So look back at your stuff, write that formula down again, but make sure you're kind of starting to get that to where you remember it, okay? So our area is going to be 1/2 A, which is 15, B, which is 18, sine of C, which is 100. Make sure your calculator's on degree mode and go ahead and type it in. All right, I got approximately 132.949. I'm just going to say 0.9. Our units is feet. Area is always squared. This would be my answer. All right, let's do the next one. So now I'm going to draw my triangle again, you guys. You got to always start with your triangle. A, B, C, B, A, and C. If A is 20, B is 40, and C is 30, well, then now we've got side, side, side. So we've got to use this other one. So we've got area is the square root of S times S minus A, S minus B, S minus C. I feel like this one's pretty easy to remember, but you have to know what S is. So S is the semi-perimeter. Oops, my pen's not working. Okay, so that's semi-perimeter. To find the semi-perimeter, that means add all the sides, so add sides, and then divide by 2 to find what half of it will be. That's where the semi comes in. So we're going to do 30 plus 20 plus 40 divided by 2. Go ahead and put that in your calculator. And you should get 45. So now we're just going to plug that into our equation, you guys. So our area is the square root of our semi-perimeter times our semi-perimeter minus A times our semi-perimeter again minus B. It doesn't really matter which one you do is which, just make sure you've gotten all of them. So B is 40, semi-perimeter minus C is 30. And now it's just a calculator problem, so go ahead and type that in. And we get approximately 290.47, I'm going to say 0.5. And then we don't really have any units on this one, so I'm just going to say units squared. So let's go to the next one. I do want you guys to try these ones first. I'm going to give you the lecture I always give you. Make sure you try them first, you guys, because that's where learning really happens. You can watch these over and over and over and over again and think, oh man, that's easy, I can do that. But when you actually do one, you're going to see where you get stuck and then see how to fix that issue. So please pause this now and try it first. All right, let's go ahead and do these real quick. So we can label these R, S, T, not a big deal, S, R, T. R is 120, S is 80, and T is 115. We've got side, 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 so we've got to use that other one that we just used. So let's go ahead and do that. So we've got A equals the square root of S, S minus A, S minus B, S minus C. And go ahead and find your semi-perimeter. So you're going to take 115 plus 120 plus 80 and divide by 2 and plug that in your calculator. And you get 157.5. So I'm not going to write this everywhere in here, you guys. We know all of these are 157.5. We know A, it doesn't really matter which one you do there. So I'm going to do 115, B, 120. The other one I need to do is 80. Go ahead and type that in your calculator. And you should get our area is approximately 4,410.636. So I'm going to say 0.6. And then we don't have units, so I'm just going to say units squared. Okay? If you didn't do the second one yet, go ahead and pause that and do that one real quick. Okay? All right, let's go through this real quick. So we've got our triangle. And it's X, Y, Z, so here's Y, xz. Y is 6. Angle Z is 127 degrees, and side Z is 9. We don't have side, angle, side here, and we also don't have side, side, side. So to do this one, we're going to have to use 2 sets of these for law of sines to find y, and then we're going to use y to find x because we need side, angle, side. So we can't use just find x right away because we don't have side x. So let's do the sine of 127 with 9 over that. So z over sine of z, 6 over sine of y, and put that in your calculator. Use your little sombrero, and you get 32 degrees once you take the sine inverse, because you get like 0.53 here equals the sine of y. This is actually capital Y. So when you take the sine inverse of both sides, you get 32 degrees equals y. So now take 180 minus 127 minus 32 minus 127 minus 32 is 21. So we can put 21 in here. Now we can actually find the area. So we have the area is 1/2 times 9 times 6, because those are the 2 sides we're using, and then this angle, so times the sine of 21, and put that in your calculator. And we get 9.7 because it's 9.67. And we're just going to say meters squared. So that's our area. Alright, let's just do this last one real quick. So it says the adjacent sides of a parallelogram measure 8 centimeters, 12 centimeters, and one angle between them measures 60 degrees. So let's just draw a parallelogram real quick. We know we need to be working with triangles, but we've got 8 centimeters, 12 centimeters, and then 60 degrees. And then if we split this into triangles, we've got 2 congruent triangles. This one has a side length of 12 centimeters, we've got 8 centimeters, and we've got our 60 degree angle again. And we've actually got side, angle, side on each of these triangles, but we're just going to use 1 and multiply it by 2 to find our area. So let's take our area is 1/2 times 8 times 12 times the sine of 60. And then go ahead and type that in your calculator. And you get 41.6. And then this is centimeters squared. This is for one triangle. So we're going to say one triangle. If we want it for 2 of them, we're just going to have to multiply by 2. We get 83.1 centimeters squared for our total area. And that's all I've got for you. That's our last example. That should cover everything. So just remember, you have to have either side, angle, side, or side, side, side. And if you don't have that, you have to use either law of sines or law of cosines to find the missing things that you need to solve these.